In this video, we're going to take a look at introducing hyperbolic functions. Now, hopefully, at this point here in your kind of studies, you are familiar with the three most basic trig functions, okay, especially if you're doing A-Level Further Maths. So remember, we've got sine of an angle, we have cosine of an angle, and we have the tangent of an angle. Now, in this video, what we're going to do is we're going to introduce the three most basic hyperbolic trig functions. So we have hyperbolic sine. Now, just a note here, there's a few different ways you can pronounce this. I call this sin x, but some people might call this sinh x. It's kind of which way you've kind of learned this, but that's the way I call it. Now we actually have an exponential definition for sin x here, hyperbolic sine, and this is equal to e to the x minus e to the minus x, so minus e to the minus x all over 2. Okay. We also have hyperbolic cosine, which we call cosh x, so that's cosh x. And again, we have an exponential definition for this. So this is e to the x. So e to the x plus e to the minus x all over 2. And then finally, we have hyperbolic tangent here. So hyperbolic tangent. Again, a few different ways you can pronounce this. I call this fan x, but you can call this tanch. Again, just which way you kind of learned this. And again, we also have an exponential definition for this, but we need to use an identity here. And pretty similar to the basic trig identities that we learn in the first year of A-Level Maths. So obviously, we think about A-Level Maths here, tan x is identical to sin x over cos x. Same here now with the hyperbolic functions. So hyperbolic tangent here is the same, or is equivalent to hyperbolic sine, so sin x over cosh x. Okay. So in that case then, what I can do is I can write this as my function here of hyperbolic sine x. So that's going to be e to the x minus e to the minus x over 2 divided by e to the x plus e to the minus x over 2. Okay. E to the x plus e to the minus x over 2. Now when I've got a fraction like this divided by another fraction, if the denominators are equal like this, they will just cancel. So they just cancel. So what I'm going to get left with then is e to the x minus e to the minus x all over e to the x plus e to the minus x. Okay. And I can actually rewrite this one more time here by considering the fact that this e to the minus x is the same as 1 over e to the x, and then just multiplying through by e to the x. So I can write this now as e to the 2x minus 1, e to the 2x minus 1, all over e to the 2x plus 1. Okay. Sometimes it might be easier to work with it in this form, sometimes it might be easier to work with it in that form, but we can write it as either of those two expressions. Okay, so remember, we can easily derive hyperbolic tangent there by using this identity here. Okay. Now let's just think about the unit circle here. So when I think about the unit circle and our trig functions, our three most basic trig functions then, and I would have something that would look like this. Okay, so I would have a unit circle. So it looks like that. Not perfect, but you get the idea. And I'm going to define a point on the unit circle here. Okay, I'm going to call this cos theta and sine theta. Okay. And we can do the same here now with the hyperbolic functions, but rather than the unit circle, we're using the unit hyperbola. Okay. So I'll just draw my axes here. Now what I'm only concerned about here is the positive values of x here. Obviously, when I draw the unit hyperbola, we'd have the negative portion here as well, but let's just ignore that for now. Okay, so it would cut through at 1 here. Gonna look say something like this. Okay, not perfect, but you get the idea. And again, I can just define a point on the unit hyperbola here. Bit of a mouthful. And in this case, then it will be cosh theta, so cosh theta, and then sin theta. Okay, so we're running out of room a little bit there, but sin theta as well. Okay, so cosh theta, sin theta. Now, you can verify this by doing, so verify, and I'm going to leave this as an exercise for you to have a go at. So verify it by using x squared minus y squared. So this is my unit hyperbola here. So x squared minus y squared is equal to 1. So that's my unit hyperbola. Obviously, we could do the same for the unit circle here with x squared plus y squared is equal to 1. Okay, that's the unit circle. Obviously, substituting cos theta and sine theta in here, then using our identities. And like I said, we can do the same here now using the exponential definition. So verify by cosh theta squared, so that's my x squared there, minus y squared, which is sine theta, and show that that's equal to 1. So I'll just give you a bit of a clue to get started then. Use the exponential definitions here. So use the fact that cosh x is e to the x plus e to the minus x over 2. But obviously we're now using it in terms of theta here. That's going to be e to the theta. Oops, that's e to the theta plus e to the minus theta all over 2. Square that. And then subtract sine theta squared. So that's going to be e to the theta minus e to the minus theta all over 2 and square that and show that that's equal to 1. Okay, I'm going to leave that as a bit of an exercise for you to have a go at. It is just basic kind of simplifying there, but do have a go at that, see if you can show that that's equal to 1. Okay, and to finish with then, I just want to mention about the odd and even functions here. Okay, so what I'm going to do is I'm just going to clear the screen just to finish with here. So in this case then, we say that hyperbolic sine here, so sine is an odd function. Okay, so sine is an odd function. So sine is an odd function. So what does that mean here? Well, what that tells us then is sine of minus x. So sine of minus x is equal to minus sine of x. Okay, that's our definition there of an odd function. And cosh is an even function. Okay, so cosh is an even function. So what does that mean here? Well, what that means then is cosh of minus x, so cosh of minus x is equal to cosh of x. Okay, that would be positive. Okay, so sine is an odd function, therefore sine of minus x is equal to minus sine of x. And cosh is an even function, so that means that cosh of minus x is equal to cosh of x. Okay, and there we have it. So that's our introduction to the 3 basic hyperbolic trig functions, and that brings us to the end of this video. So in the next video, we're going to start taking a look now at differentiating hyperbolic functions.